schedule stuff doesn't change, who needs to be PLC lead for regular next year?
Well, I mean, or your other deals, we're all together at the same time. Dues, like Pamela and I, plus regular, all together first and split it, or maybe every other week. I don't know. I don't hear.
Until it's gonna be hard for y'all to do that.
Except for the fact that I put a lot of work into creating a differentiation between regulars and others. But you're right. And it is
Why don't we have this set up?
right, but it depends on your. Well, I don't know. And the majority of it depends, like during volleyball, this is sometimes it's wrong, like that usually in the beginning of the day. Yeah, he's in there too, and I was gonna meet him. I've met him once, and I don't know how that works. You know, I'm like, I work for longer now.
You'll miss the mini quiz, so that'll give us some minutes to make up.
I think I could do it on Friday during class.
Maybe at the end of class, and then this.
Okay, thank you.
So, if you want that link up there.
I got him so good.
No way, basic algebra 1.
Like you told me you pitched on varsity, right?
Hard. It's basic algebra
Huh?
1.
Occasionally.
Occasionally? Okay. Somebody was telling me it's not that much.
Not recently.
Not recently. Clear your desk for mini quiz?
That's not for us. But it says.
What class is that? Oh.
Yeah.
I was like, that's weird.
Oh, yeah.
This is yesterday as well, yeah.
Look for the water.
Nice.
There's some
Interesting way to have, I mean, math.
Have you seen that before already?
Me?
The wrong thing. Oh, dude, you did kind of the same thing with with Minesweeper. Making a step like ground pound on the other day. That's pretty funny. I don't remember if it was the same dude or not.
Let's go! He is way too math just
God, I didn't miss any new content.
Did you take the test today or just the test? And the quiz?
No. My whole.
There's only one question I never focus on because it's like 50-50. And then on the quiz, he said it was true and false. I had my false to be true, but I
So 2 days with that.
I'm looking at
Yeah.
a 95, whatever it is.
I think you probably had a lot more fun.
No, it was crap. The only fun part was the student social, which was literally a giant raid.
That's not the least.
I almost fell asleep like every hour of every day in that room.
Brandon's like, no, I don't think you did.
Sorry, those performances, some of them were really boring. And I'm like, anyways, I was just like really drowsy because my whole schedule was screwed up because of the way of there. And like, you know, eating pizza, eating dinner at like 12 at night.
Haley. Christian School Business.
Yes.
Hey, Ben, you're marked. Ben, you're marked as parent contact.
Yeah, I'm going
I just letting you know I can't.
You're not gonna get raised.
I can't change it on here. So. Okay. So let's. Oh, I'm sorry. This is my calculus class. I was trying to see what I need to change for tomorrow. Here we go. Okay, so you got 3 new handouts today. We are finished with logarithms, short of if you don't meet the requirements to exempt the final, then I guess you'll have to review logarithms for that. But short of that, we are done with logarithms for the year. And so we've got a handful of other algebra things that we're going to do, but most of them, well, not most of them, all of them will be much quicker than logarithms. Logarithms is very much a deep dive into the unit. So the first one that we're looking at is section 1.1. So this is all the way back to the beginning of the textbook, and most of this stuff should sound familiar to you back from even as far as Algebra 1. It's a good review for ACT as well. But there should be a few things in there too that you should have seen in Algebra 1, but typically you guys don't, just because you don't, like, you run out of time in Algebra 1. So, but these are the things we need you to know moving forward, things that teachers will expect you to be able to do and know about coming out of pre-calculus. So 102 is worksheet 1, and I'm going to do all of that with you with a little bit of feedback from y'all so I know how it's going. 103 is basically the same question types. I'm going to ask you to do that one independently before we check the answers to see if this quick reteach on handout 102 is enough. And then finally the shortest handout, the extra practice 104. It's just a couple question types of the ones that students usually ask for extra practice on. So those 3 handouts make up section 1.1 and what you need to do for that. And again, it is just a 1-day lesson, so I will not see you guys again until next Monday because this is a B week. But next Monday we will have a quiz that is similar to this worksheet 1 and similar to this worksheet 2. So you need to make sure that you speak up and get the help that you need to today. Okay, so questions 1 through 4 say write an equation for each described line. You may write your answer in any one of the 3 formats that you may have studied in Algebra 1 or Algebra 2. So typically in this, students seem to prefer what's called slope intercept, which is the mx plus b. And there are a couple of questions that specifically say put your answer in slope intercept. However, I am going to focus on something called point slope, which I think you've seen, but you probably didn't practice a lot. The reason why I focus so much on point slope is because this is practically what we use in all higher mathematics. And to be honest, it's easier overall. It's less work to write something in point slope. So to do point slope, you just plug your point. You need a point and a slope. The point that you know goes in for x1, y1, and the slope you want the line to have goes in place of m. So looking at question 1, I've got 2 points to pick from. So I just by default will always use point 1 just to make it a little bit easier to see what to do, but there's nothing wrong with plugging in point 2. So y1 goes in here, x1 goes here, but minus a negative, we would write that as a plus. And then really the last thing before I have my equation in number 1 is I need the slope. So you've got 2 options on how to go about find slope. I guess since this is linear stuff, you could make a graph, you could plot those 2 points, and you could carefully count rise over run. But honestly, much quicker and less prone to careless mistakes is going to be the slope formula, which is good for you guys to review for ACT anyway. Subtracting the y values is how you compute the rise, and subtracting the x values is how you compute the run. So subtract the y values, and then in the same pattern subtract the x values. Looks like the slope would be -3. So if you know point slope form, plug in x where it goes, plug in y where it goes, find the slope one of two ways, and then plug that in for m. Okay, skipping down to question 4 because it's similar. It also gives you 2 points. So let's just use the first point for point slope. Subtract the y value here, subtract the x value there, and then the only part that should take a moment to think about is slope. So subtract the y values, and then in the same pattern subtract the x values. Looks like this slope would be 5/2. The only thing I would probably do before circling my answer here is subtracting 0 doesn't do anything, so I guess it's not wrong to leave it in your answer, but there's no need to. Now, I'm not going to dwell on this, but on question 1, based on the directions, if you really want to put this in slope-intercept form, bless you, you can, but again, it's more work. So if you really want it in slope-intercept form, you need to distribute the -3 and then add over the 6. That's fine as well. But again, I don't know why you'd want to do more work and run the risk of making a mistake and do more work. So point slope is what I'm going to lean on. Okay, question 2 says let's go through this line, and it needs to be a horizontal line. So this brings up that you need to remember a few things about horizontal lines and a few things about vertical lines. Horizontal lines look like this. If you took 2 points on this and did rise over run, you would get 0. The slope of the horizontal line is 0. And because the way this line is, it doesn't matter what x value you have, it always has the same y value. Its equation will be y equals a number. We don't need this on this question, but eventually today, vertical lines, you need to know what they look like. If you took 2 points on this and did rise over run, you would try to divide by 0, so your slope is undefined. And a vertical line would have an equation of x equals the number. Now, really for question 2, the only thing you have to know is this. Horizontal lines have a slope of 0. Because you already have a point, plug in 5 for y1, plug in -1 for x1, and if you know horizontal lines have a slope of 0, you already have the slope. 0 times anything is 0, and then you can add the 5 over, which notice it ends up in that format even if you don't memorize it that way. Okay, and then the last one of this section, and then I'll pause and give you a chance to speak up. If you're given a point, plug in the x value and the y value into point slope, and again, you're almost finished. But instead of giving you 2 points and using the slope formula like questions 1 and 4, instead of telling you it's a horizontal line, which is basically telling you that it has a slope of 0, you also need to remember some stuff about parallel and perpendicular lines. So since this one is in mx plus b, we know that this guy has a slope of 4. Now, if it had said parallel, what slope would I want to use? 4. Parallel lines have the same slope, but perpendicular lines, what slope should I use?
-1/4.
Very good, -1/4. So it's called opposite reciprocals or negative reciprocals. So the reciprocal just means you're flipping over the fraction, like we did a ton last semester. But the opposite or negative means that if this guy's positive, this guy needs to be negative. So parallel lines, same slope. Perpendicular lines, opposite reciprocal slopes. And of course, if you forgot that, then you may want to put that in words for your notes. Yeah.
Can you show me 2 real quick again, please? Gotcha, thank you.
Okay, so all of these are pretty similar. How to find the slope can vary depending on the information you have But again, point slope, if you're not familiar with that, I strongly suggest that you get comfortable with that today because it makes your life easier. But anything you guys would like to follow up on 1 through 4? Any immediate questions? All familiar so far? You remembered this about horizontal lines and vertical lines too? Okay. All right, the next part is not difficult, but this is one of the things that typically students have not seen before. It's an Algebra 1 topic. Usually Algebra 1 teachers delay this, and then it's one of the things that they don't get to. But these are direct variation questions, and you only need to know 2 new things to be able to do direct variation. When it says direct variation, it's implied that it goes through the origin, so there's really a hidden point here. And 2, there's something called constant of variation, which we sometimes use the letter K for, but it's just a fancy way to say slope. In direct variation, instead of saying slope, we say constant of variation. That's the only 2 new things you have to know for these question types. Because question 5, write an equation that goes through 2 points. This is just like questions 1 and 4. Pick one of the points. I'll use this one. Actually, no, I'll use 0, 0. 0, 0 is really easy to work with. Plug in 0 for x, plug in 0 for y, and then to find the slope, well, you've got 2 points. So subtract the y values, subtract the x values in the same pattern, and since subtracting 0 doesn't do anything, we might as well make it look a little bit nicer. So same skills as above, but you need to know it goes through the origin for part 5. And then in part 6, when it says find the constant of variation, it's really saying find the slope. So if it goes through 0, 0, and it goes through negative 1/3, 6, subtract the y values, subtract the x values in the same pattern, and now be careful dividing fractions. I know we did that a million times last semester, but dividing by 1/3 is the same as multiplying by his reciprocal. Constant of variation, slope is just negative 18. Now, this one actually has a second question to it too. Then find the value of y when x is negative 2. So how could we figure that out? Well, how could we figure out the y value when x is negative 2? Or what would maybe give us that information?
Just find the equation of the line and put it to it.
Good. So this doesn't say you had to find the equation of the line like number 5, but what you need to understand is if you already have the slope and you have a point, especially something like 0, 0 that's insanely easy to work with, the equation of a line is basically a formula to get you any point that you want. So when x is negative 2, looks like y would need to be 36. So just understanding that the equation of the line can get you points. So we will practice a couple more of these. Well, you'll have another one of these on worksheet 2 to see if you can actually execute it with more of a reminder than that. And then we'll practice it a little bit on the last page. Not because it's difficult, just that it's different. But the parts that you need to circle and highlight, direct variation implies going through 0, 0. And instead of calling it slope, we call it constant of variation and sometimes refer to it as k instead of n. But no other difference otherwise. Okay, back page has quite a bit of graphing. Graphing is the majority of it. Now, if I ask you to graph number 7, how would you go about doing this?
I would get y on one side.
Okay, so solve this for y by subtracting a 2x and dividing everything by negative 3. Why is that good?
Because that gets us into slope intercept.
Okay, so very quickly, we can see the y-intercept is -4, which is 1 point. We've got the slope, so we can count up 2, right 3 to get a second point, up 2, right 3 to count a third point, up 2, right 3 to get a third point. This is a linear line, so you really only need 2 points, but you can do more if it helps you make your line look straighter. So, from the front page, you know I'm not a big fan of slope-intercept. I think slope-intercept is a touch easier to graph, I guess. But it is pretty handy in these situations. If it doesn't fit one of the forms we know, just solve it for y equals to get it in slope-intercept. And on this topic, let's look at the bottom left question, because this one specifically asks us to just put it in slope-intercept. So that's the y equals mx plus b, which basically just means, do you know to solve this for y by subtracting 2 x's from both sides and dividing everything by -5. Nice way to graph some equations if it's all kind of scrambled up. Just unscramble it to y equals, and then you should get what you need. Okay, for the next graphing part, x equals 4, what should this look like? Good, so first off, recognizing that this is just a vertical line, and it is the vertical line where x always equals 4. Hence the equation x equals 4. No matter what y is, x is always 4. So that can be super easy as long as you remember what you need to remember about absolute value. Okay, we got piecewise function, and I was thinking we had done some of this first semester. We did? Okay, good.
So,
Okay, good. And then I wasn't sure if I blended it in with last year or not, but okay, so piecewise functions, typically you guys make these much harder than they need to be. If you can graph y equals -4, which is a horizontal line, y equals 3x minus 2, which is slope-intercept, graph the intercept, use the slope to find a second and third and fourth point, and graph the last equation, y equals 2, which is another horizontal line, you're almost finished. The thing about a piecewise function is you shouldn't be graphing all 3 of the parts. You really should only be graphing y equals -4 during this time with his restriction when x is less than or equal to -2. So the fact that it says equal to means it needs to be a closed circle, and less than would be the values to the left but not the values to the right. Do the same thing with the middle one, -2 to 1. So from -2 to 1 should be the only times it exists. Looks like it can equal 1, so that's a filled in circle, but it doesn't say include -2, so that needs to be an open circle. Should not exist to the left of -2, and it should not exist to the right of +1. And then the last restriction, y equals 2, should only exist when x is greater than 1. So not equal to 1, so open circle. Greater than 1 would be the stuff to the right, but not the stuff to the left. So piecewise function is telling you exactly what to do. You just have to make sure that you can read those inequalities and graph those 3 lines to start with, I guess. Now, this will not confirm that your answers are correct, but it will help you maybe catch some mistakes if you're wrong. What does this f of x mean?
Y.
Okay, yes, it also means y, but it also means something else that starts with an f. It's a function. And what has to be true about a graph for it to be a function?
Oh, it's gonna pass the vertical line, yes.
So if your answer does not pass the vertical line test, your answer is not a function, which goes against this. This implies that it is a function by calling it f of x. So notice, even at x equals -2, my graph hits here, but not here. At x equals 1, my graph hits here, but not there. So that would be bad if these were both filled in. That would be a red flag that something's wrong. Of course, it could still be wrong in a different way, but. Okay, and then finally, we need this for the last question, but it is good for you guys to remember what the absolute value of x looks like. This is a parent function, and of course, the -1 right next to x is going to shift it right 1. And that seems a little bit random, but we will need to use this on the last question on this page. Okay, this one's, well, I don't think many of you have practiced this, if any of you have practiced this, but this is probably the most involved one. So even if you feel like you've been coasting here, you need to make sure you're giving me your full attention on this, please. You had enough? No, I'm just messing with you. Have a good day. Okay, you can change absolute value functions into piecewise functions. That's why we just did a graphing piecewise function and we just graphed an absolute value function so that you got kind of a reminder of those. Now, before I dive into this question, let me show you the easier one, and I'm going to do this on our last handout today as well. But the classic example is absolute value of x, which looks like this. Can you see how this is like two different linear equations? It's like you've got this one that has a positive slope and this one that has a negative slope. See how you can split that into two parts? Well, what is the y-intercept of each of those? Okay, so b is 0. What is the slope of this line? So 1x. And what's the slope of this line? -1. So negative x. Of course, adding 0 doesn't do anything. But what I need you to see for the first part of our answer here is that half of this comes from what's in the absolute value sign, unchanged, and half of it is the exact opposite of that, so multiplied by -1. So for our question 12, half of it is going to be 3x minus 1, and the other half is going to be the opposite of that, -3x plus 1. Same way that this is working. It's just that this one's a little bit easier to see, but similar format. Okay, we also have to come up with some restrictions here. So when does it stop being the purple line and start being the red line? Okay, so right here, when x is 0, so x compared to 0, how do I know if I want where x is greater than or less than for this top piece?
It's greater than.
Okay, the part that has a positive slope exists when x is greater than 0, and the part that has a negative slope is when x is less than 0. Yeah. Well, that's what I'm going to ask y'all. What do you think? What happens if I don't put an equal to on either one of these?
It makes a hole.
It won't touch.
Right, then technically there would be a hole here, which they're not supposed to be. So you can include an equal to here or here, but not both. It doesn't matter which one you tack it on to. Okay, well, I guess this doesn't really go with the question. This is just helping us.
Why not both?
Well, because it's like you're hitting the same point twice, so it's not needed. Okay, so for us up here, now I don't know exactly what this graph looks like. This would be a horizontal shrink by a factor of 1/3, and this is going to shift it right 1/3. But if you don't remember those more complicated transformation rules, at the very least you need to say, all right, well, it's an absolute value function, so it's going to look like a V. And since we're subtracting from x, it's going to get shifted a little bit to the right. So I'm going to try to color coordinate this for you. The one with the positive slope is like this, and the one with the negative slope looks like this. But what I'm really interested in is this point right here. I need to know when it stops being this function and starts being this function, because that's going to set up my restrictions up here as part of my answers. So what is true about this point?
0, 1.
It's
Or
0,
yeah,
1 would be up
0.
here. Okay, what is your other guess? It's also not 1, 0. I'm not asking what you think the point is. I'm saying tell me something that you know is true about this point.
To the right of the word.
Okay, it is to the right. What else?
It's an intercept.
Which means y equals,
0.
okay, everyone can agree that this point has y as 0. Well, this line intersects y equals 0, and this line intersects y equals 0. So you could either set this equal to 0 and solve, or you could set this equal to 0 and solve, and it shouldn't matter at all. You should get 1/3. That's where it's switching off. Don't just guesstimate it in your head and think that it's going to be 1. It would be 1 if there wasn't that 3 there, but that 3 does a horizontal shrink by a factor of 1/3, and so unless you remember those transformation rules, we've not reviewed those this year. That's probably not a great approach. But I want the ones to the right of this one and to the left of this one, and I need to include at least one of those, but not both. So this is what we were aiming for. So this part should be pretty quick. The stuff under the absolute value, the opposite of the stuff under the absolute value. But then you need to find where it's switching from one to the next, and that takes a little bit more thought. You can't just go straight to the answer on that. Okay, so I feel like at least most years that's 100% new for people, at least this one is, but the point slope shouldn't be 100% new, slope, vertical, horizontal line shouldn't be new, parallel perpendicular line shouldn't be new, vertical horizontal shouldn't be new. I may have listed that one already, I don't know. So scan through here real quick, see if there's any clarifying questions you'd like to ask before I ask you to try worksheet 2. Anything that you know that you're going to need help with. Okay, then let me give you about 15-20 minutes to try worksheet 2. It's very similar to worksheet 1 as far as question types, and so this should give you some quick feedback on just our quick little reteach and showing you a couple new things real quick. Caroline, you need to put your name on the board. And then so we'll check the answers to that and then go over all of them that we need to go over. Again, this is just to try to give you some quick feedback on what you actually need to review. So, don't use your notes, don't get help from each other. Just try it out and see how it goes. let's give everybody about 4 more minutes. 4 more minutes will be almost 20 minutes. Okay, so that was just under 20 minutes. So let's start off by checking answers first. And then we can go over all of them that we need to go over. So 1 and 2 did not match up with worksheet 1, but that was just plugging in and finding a point. So that's an easy thing to go over if we need to. But 17 for number 1, 2 for number 2. Number 4 was just a horizontal line, so y equals 5. Number 3 and number 6, we needed to use the slope formula to get the slope and then plug in either one of the 2 points. I just went ahead and used the first point just for consistency. And then on number 5, they gave me the point to use, and I used a slope of 2. because that line has a slope of 2 and parallel lines have the same slopes. Okay, number 7, direct variation. So I know that means it goes through the origin. So I basically have a second point, and if I have 2 points, I can solve for the slope. And if I have a point and a slope, I can do point slope. Easy way to write the equation of a line. Number 8 has 2 questions. The first is to find the constant of variation, which was just the slope formula. I got -8. The second one was find the y value when x is -3. So I took the slope, I took the easy point 0, 0, made an equation, and then just understanding that the equation of the line is basically like a formula that will get you points. When x is -3, y needs to be 24. Yes.
If I did 7 with 0, 0 instead of the other points, would it still be right?
You still got 24, didn't you?
No, 7. The problem 7.
Oh, yes, yeah. It's just that if you use 0, 0, you probably shouldn't write the -0, -0, so like yours could look like this. Yeah, that's fine. Same thing. Again, it doesn't matter which points you use. So, all right. On the back, graphing number 10 was just a vertical line, so you shouldn't have taken more than about 10 seconds on that one. Number 9, if you solve it for y equals so that it's in slope-intercept, you have the y-intercept and the slope, which is more than enough to get at least 2 points. Number 11, you had to do in 3 parts. Y equals 4 and y equals -2 were horizontal lines. I did those in red. And then the middle one was mx plus b, but then making sure that each one only exists based on the restrictions given to you on the right. And then number 12 looks like the standard absolute value of x equation, but shifted right to. Okay, number 13, solve it for y equals so that it's in slope-intercept, mx plus b. And then 14, change that to a piecewise function. So part of it comes from what's under the absolute value. The other part comes from the opposite of what's under the absolute value. But to see where it switches from one to the next, you could make a sketch. Even though my sketch is not accurate, I know it was moving to the right some. So it's not at the origin, it's somewhere to the right. This point that I have highlighted is the point of interest. It has a y value of 0. So you could either set this equal to 0 and solve, or you could set this equal to 0 and solve. You're going to get the same value because you're talking about the same place. And when I did that, I got 4/3, which is how I knew this. And I knew to say bigger for this one because that's where it's to the right of that x value, and less than on this one because that's where it's to the left of that one. Okay, which of these do you need me to put back up and discuss in greater detail?
I just mixed up perpendicular and parallel.
You got this though?
Yes, sir.
Yeah, Tyler.
Could you show me 11 form, please?
Any part of that you want me to go over, or just you need to see it?
No, I just messed up one of the points.
Again, if y'all missed number 11, one of the few hints I can give you to help you check your work. This implies it's a function, which implies it passes the vertical line test. If you got something different, you need to see that yours doesn't pass the vertical line test. Any x value you pick should hit your graph at most once. And if that's not true, then you should know something's off. Okay, if y'all are sure. Let's move on to the last part then, the last handout, the short one. So after a few years of doing these, and these were the question types that students felt not necessarily the hardest ones for everybody, just the ones that are less familiar. So I'm going to reteach one more direct variation, one more graphing and piecewise, and 2 more changing an absolute value into piecewise functions. and then I will ask you to try one of each of those types of guided practice to wrap things up here. So direct variation means that it goes through the origin, and it means the constant of variation is called slope, or instead of slope it's called constant of variation. But if you know it goes through this point and it goes through this point, slope formula, and then be careful dividing fractions. Dividing by -1/2 is the same thing as multiplying by -2. So there's the constant of variation. And then second half of the question, what is the y value when x is -5? Now, I don't know if this is the only way to get it, but if you have a point, especially 0, 0, that's the easiest point to work with ever, and you already know the slope, you could, in just a second, make an equation of the line, and then the equation of the line is like a formula for all points. So when x is -5, it looks like y needs to be 40. So I'm not doing anything different than you should have done on worksheet 2 and then I did with you on worksheet 1. It's just most people haven't seen this before, so I'm just making sure that you get in a touch more practice. So finish copying that one down, please, and then try the same thing on question 2. Okay, did you get 3 and 9 as answers? Constant of variation is 3 because that's the slope. And if you make the equation, plug in 3 for x, solve for y. Y is 9 when x is 3. This is the last one of these that we're looking at today as a group. So anything about that I'm flying through? You're okay with that? Okay. Then let's look at another piecewise function and have you try one more. So this one has 3 pieces, although piecewise functions can be in as many pieces as they want to. 2 and 3 are definitely the most common though. So sometimes it should be y equals 5, which would be a horizontal line where y is always 5. But we want to be sure to only keep the part where x is equal to 4 or greater than 4, which would be to the right. So none of the stuff to the left. In the middle, it should be y equals 2x minus 5. So y-intercept of -5, slope of 2. he should only exist from -2 to 4. It does not include -2, it does not include 4, so open circle on 4, open circle on -2. And then the last part, y equals -6, would be a horizontal line where y is always -6. But if you include the whole thing, notice how this doesn't pass the vertical line test, which means it's not a function, and this f of x implies that it is a function. Should only exist when x is equal to -2 and less than -2. So that's what it should look like in the end. So finish copying that one down and try one more time. Make sure that there's not anything else you'll need to ask. Okay, and here's your answer, what your final thing should look like. So the top equation, y equals x, was only supposed to exist here. In the middle, y equals 2 should only exist between those x values, and y equals -x minus 5 was only supposed to exist for those x values. So on one hand, I mean, I guess they're a little bit harder because there's more to them, so more places to make a careless mistake. But if you can graph those three things and you can read these inequalities to know what part of each graph to keep, then it shouldn't be any more complicated than that. Try not to overcomplicate it. Okay, this is the last one of these we'll be looking at today as a group, so anything y'all want to ask about that? Okay, then on to the last one. So, changing an absolute value into a piecewise function. So I did this one for you on the first worksheet, but it's okay, you can go ahead and copy it down again. This is the classic example. This is one that's a little bit easier to see. Sometimes the equation is y equals x. Sometimes it's y equals -x. And because we happen to know what this graph looks like, it makes sense that it starts being the red function when x is greater than 0, and it was the purple function when x was less than 0. To make sure we get this point here, and it's not a hole though, you need to include it in one of these two. It doesn't matter which one. But using that as a baseline, we can steal some of the logic here to help us with a question like this. Because just like this one, the stuff under the square root was part of our answer. So the stuff, our absolute value, sorry, the stuff under the absolute value, so 2x plus 1 is one part. This is the opposite of that. So the opposite of 2x plus 1 would be negative 2x minus 1, multiplying it by negative. Unlike this one where I know it's switching at x equals 0 right here, which is why I used 0 and 0. On this one, I don't know that because I don't know exactly what this graph looks like. It's going to be shifted left some, but not left 1. Because of this 2 and the horizontal shrink, it's actually being shifted left 1/2. But for a visual, you can shift it some left. See that this point is when y equals 0, and you can either set this equal to 0 and solve, or this equal to 0 and solve. Shouldn't matter at all, because this line and this line are at the same place, same time when y equals 0 anyway. So negative 1/2 is where it is switching from one piece to the next. And to know which one's which, again, this is where it helps to have a little bit of a picture. The positive slope part is to the right, and the negative slope stuff is to the left, and then you need to include one of these two so that there's not a hole there. Okay, so to finish up, go ahead and copy that down and try one more time on the last one. Anybody need longer for this last piece? Okay, so again, I think this is the hardest part, but you shouldn't take very long to know. Part of it was 4x minus 2, and part of it was negative 4x plus 2, because that's always the case. The restrictions take a little bit more thought, but this is going to shift some to the right. It's an absolute value graph, so I know it's still going to look like a V. But with the picture, I can remind myself it's switching at y equals 0. So you can set this equal to 0, plugging in 0 for y, or this. Both of them should be fine. They should give you the exact same number. In fact, if they don't, then that's a red flag too. So that should be 1/2. And then the other thing a quick little picture can do is the positive slope is the stuff to the right when x is greater than 1/2, and the negative slope stuff is to the left of 1/2. And to make sure that there's not a hole there, you need to include it in one of the two. If you do neither, it's not correct, fully correct, and if you did both, it would not be fully correct. We don't want to hit the same point twice. Okay, so this is the last one of these today. Any follow-up to that you want to ask? Okay, so in a perfect world, you guys all remember the review stuff: vertical lines, horizontal lines, parallel, perpendicular, slope intercepts, how to graph those, how to graph absolute value functions. And then a couple of these are probably new to you and need to be a little bit reviewed. But we will quiz on this next time. And so the quiz will look just like worksheet 1/worksheet 2. Both of those look very similar to the quiz. So certainly not trying to trick you or anything, but these are the things we need you to know. So if you have forgotten some of that, or you need to review some of that, then please do. Since this is a B week this week, I will not see you again till Monday, so probably extra important that you make yourself some sort of reminder about the quiz so that you're not caught off guard. And even though you should have all 3 of those handouts done, I will ask for them the day of the quiz to give you some participation points. So that's all I've got for you. Yep, that helps. Oh, did y'all get the daily meme?
Yeah, that was funny.
What?
The meme?
Oh yeah.